Now we shall discuss about the term factor of safety, which plays a major role in your design. So factor means it is a constant. And safety, you know it. So a constant which is considered for the safety of the machine element which you are going to design, that is called as factor of safety. Okay. So before discussing about factor of safety, let us understand the concept of strength. So you know that stress is equal to, what is the formula for stress? Load by area. So this is what you have used. So you have determined the stress when you are given with load and diameter. So if you take a cylindrical shaft, then the diameter is given. Okay, so pi by 4 d square will be the resisting area. So this area is called as resisting area. So load by this resisting area will give us stress. In design, you are going to determine the resisting area, thereby the dimensions. So for that purpose, you should have the value of stress and load. So how do you get the values of stress? This value of stress is the maximum stress a material can withstand. A maximum stress a material can withstand. So that is called as ultimate. So here the stress means it is the maximum stress a material can withstand. For example, you have taken mild steel. So for mild steel, there will be a maximum stress value. It is a fixed value. Okay. So that has to be taken here. And this load depends upon the working conditions in which our component is going to work. So you will be given with the maximum load that may occur on the component which you are designing. Then you have to choose proper material. So once you have chosen the material, then for that material there will be a maximum stress value. And that those stress values will be there in design data book. So you have to take that maximum stress value. You are given with the load and you are given with the maximum stress value. Then you can determine the resisting area. So how do you get that? So this resisting area is equal to this load by stress. Once if you get the resisting area, then resisting area is equal to pi by 4 d square if it is cylindrical section. Then you can easily determine d value. So in any design, more the resisting area means more the load it can withstand. How? More the resisting area means minimum the load, lesser the stress. See for example, let us come to this formula once again. Okay. So stress is equal to load by area. So when load is constant, if you can increase the stress value, area, then what happens to the stress? If you increase the denominator, what happens to the stress? Decreases. Is it right or not? If you decrease this, the stress will increase. You just remember this concept. If the resting area is more, that means more resistance. So obviously stress will be lesser. The resting area is less, that means the stress will be more. Okay. Now you have designed a component at a load of, say for example, 10,000 newtons. Okay. And the stress value is, the maximum stress value is say 500 newtons per square meters. Now what is the resting area? Tell me. This formula. Okay. So the resting area will be now this load 10,000 by 500. This is 20 resting area square meters. So from this you can determine the value of D. That's fine. So your design is to have a resting area of 20 square meters. Right? You have designed it. You have manufactured a component and it was put into use. So it can work safely as long as the load is 10,000 newtons. Fine. But do you expect that the load will be 10,000 every time?
No, sir.
You know that. You have an idea that the load can be maximum of 10,000. But there may be unforeseen circumstances in which the load may increase beyond the 10,000. Then what happens to our component? It breaks. Why? Why it breaks? Because if, for example, if the load is 20,000, okay, and our area is 20, then what is the stress value? 2000 newtons per square meters. Huh? By? Okay, 1000, sorry. So 1000 newtons per square meters. But the maximum stress that material can withstand is 500 only. But the stress developed is 1000. So obviously the material will fail. Is it right or not? So that's why our design should not be based on the maximum stress value. So for that purpose, what we do is we choose a lesser value of stress. So when the stress is less, area will be more. Is it right or not? If the area is more, stress is less. So if assume the stress is less, then the area will be increased. So as the area is increased, it can withstand higher loads. Do you get the point? So that's why you have assumed a lesser stress value. You have assumed a lesser stress value. See, so for example, this is the 500. Now I assume that, say 400. So I will design at, even though it can withstand 500, I will make my design at 400 only. Then see, now you have designed it at 400. Now what is the area? Resting area is equal to 10,000. Load is 10,000 only by 400. So how much?
25.
It is 25. Now the area has been increased. Is it okay? Now even though the load is 10,000, in some cases the load may increase. So for example 15,000 or 20,000. In such cases it can withstand because the area is more. As the area is more, the stress developed is less. Now calculate the stress. So for example, ide తీసుకుందాం 20,000 by 25. ఎంత వచ్చింది చెప్పండి అది? 800. Stress తగ్గిందా లేదా? Of course, here it is still more than this one. Here also the component will fail, no doubt. That means still you have to choose a lesser value. So enta? So 400 is not okay. So let me take 300 here. Now what is the resting area in this case? 33.33 square meters. Okay. Now substitute here. If the load is 20,000, 33.3 enta? 600 point. So ఇంకా తగ్గింది కదా? So this is also not sufficient. Then I will choose somewhat lesser value. So let me take 250. Now it will be 40. Now substitute here. 40. Exactly 500. Now the stress is exactly 500. Now our material is safe. So from this, what can you conclude? Here, instead of taking the maximum stress, if you choose a lower value, the resting area will be more so that it can withstand higher loads. So because loads cannot be predictable. Loads cannot be predictable. Here we have taken this 10,000. It is a normal load. Usually 10,000 ఉంటుంది అంతే. But sometimes it may increase. It may increase to 15,000. Usually 10,000 will not be 20,000. It may increase to 11,000 or 12,000. So in such cases, our material may fail. So for that purpose, we are assuming a lesser stress value. So that lesser stress value is called as working stress. It is called as working stress or design stress. Working stress or design stress. Now come here. So what is the maximum stress or ultimate stress? Maximum stress is also called as ultimate stress. Ultimate stress is equal to, how much is that? 500. And design stress is how much? Here we have taken it as 250. Now, ratio of these two is called as factor of safety. So this factor of safety is equal to ultimate stress by design stress or working stress. Is it clear? Now what is the factor of safety in this case? So here it is 2. Is it right or not? It is not percentage, it is a number only. Factor of safety is a number only, usually greater than 1. Factor of safety is always greater than 1. Remember that. Sometimes it may equal to 1. In such cases, design stress is equal to working stress. Okay. So when you are designing any component and when you are determining the dimensions, you have to assume proper factor of safety. And this factor of safety depends upon the material of the product and the process and the working conditions in which the component is going to work. Okay. So this is factor of safety. It is the ratio of ultimate stress by design stress. Design stress by ultimate stress కాదు. It is ultimate stress by design stress. Okay. Right.